Okay, so I'll try to keep this under 3 minutes. But so this is my project that I was working on. This is basically implementing SSAO inside of a deferred shader that I also built up. So the idea was that we have the deferred shader, which contains the three main buffers for the normal, specular, highlights, and just the diffuse textures, as well as a position buffer. So those four buffers are combined in our lighting over here to create what you see right now. But we can also add some cool little ambient occlusion effects over here. It is pretty expensive, so when I turn it on, we can noticeably start getting real slow. But perhaps you can see around the body over here and in the corners that we see some shadows, and that's just all SSAO is doing, is adding some ambient occlusion. And because we're using a deferred shader, what we can see is we can select the buffer and see exactly what is getting sent to our shader when doing the lighting computations. So we can also adjust these in real time and see how they affect what is being sent. So do kernel radius and kernel samples. So kernel samples is going to see how many vectors we're going to sample from a hemisphere that is placed on a surface normal. And kernel radius is going to affect the size of that hemisphere that we're sampling from. And the bias is just to it's just a bias to basically get rid of any weird acne effects that we might see. So over here we start seeing these this little weird pattern show up. So we don't want that. We want to set bias to be something like that, kernel radius to this, and of course less kernel samples is going to make a more performant shader. So maybe we can do something like this and get away with some faster SSAO. So if we go back to lighting, it's still pretty slow, but we can see that in action, and then again we can toggle it on and off. And this can be enabled with escape, so just pressing escape there, and you can quit with Q. And diving into the code, I basically took the renderer that we had from class and updated it to add that deferred shader. So that's what took the most time, is making sure that this was all working perfectly, and thanks to RenderDoc I was able to get that debugged properly. But we basically have four shaders. We have the two SSAO shaders, one for the actual computation. So that is going to be inside over here. And then we have a blur fragment shader. That is just going to add a little blur effect to make it look a little nicer. And then we have those four. We have a lighting shader and then a geometry shader. And then the G buffer that contains all the position normals and albedo plus specular. Specular is being stored as the alpha value here. And then creating the SSAO frame buffers, generating a noise texture for the random sampling, and then configuring them all. This is where, down here in this render, is where we're doing the four passes. We have the SSAO pass, the blur pass, and the lighting, all happening after geometry pass. So four in total, and we have 5 lights in the scene in the top 4 corners and in the middle. And also, I had to, the thing that really got me stuck was figuring out why my lighting computations weren't working. It turns out I had to convert everything in a deferred shader from world space to view, which I did not notice was the issue for a long time, because that's what the tutorials I was going off of were based on. So finally figured out that the issue was that they were in the wrong space, so I had to do a couple of changes to the vertex shader that I had originally, I believe, over here, to use a view model matrix when calculating your TBNs, and also going into our lighting, which is inside over here, making sure that we pass in a view matrix that we can multiply the world light positions by, so we can get everything in view space. So yeah, that's mostly it. And more instructions, I guess, or controls are inside the README. So thank you.